Hello students, today we are going to discuss about the uniform gradient series annual equivalent amount. So in the last class we were discuss about the present worth and shrinking method, right, and so on. And this method, the main objective of this mode is investment is to find the annual equivalent amount of a series with an amount A1 at the end of the first year and with the equal increment g at the end of each of the following n minus 1 years with the interest rate of I compounded annually, right? So we already discussed about the equivalent amount method. So every 1 year or every completed 1 year we have to pay the equal amount, right? So it is denoted as A. But in this case, so same method, but additionally we have to add increment amount. You can see this cash flow diagram. Initial first year we have to pay A1, and the next year we have to pay the equal amount plus additional increment amount plus G, and the next third year 2G, fourth year 3G, likewise. At the end of 10th year, A plus n minus 1 and corresponding G. So this is the cash flow diagram for the um, uniform gradient series annual equivalent amount, and corresponding formula to find out the A is equal to A1 plus G into 1 minus 1 plus I power n minus multiplication of interest rate and the number of years minus 1 and divided by I 1 plus I power n minus I. This is the one of the way you can find the formula, or you can find the A. And another method, you can use the interest table to find the gradient series factor, uniform gradient series factor, A by G for the particular interest rate for a particular year. You can able to find the value and you have to multiply with the G and you have to add with the A1, then you will get the uh, annual equivalent amount. And we will see one example. A person is planning for his retired life. He has 10 more years for the service. He would like to deposit 20 percentage of his salary, right? So 20 percentage of his salary, which is 4,000 at the end of the first year, and thereafter he wished to deposit the amount with an annual increase of rupees 500. We already discussed, right? So he has to additionally put the amount, the increment amount. First year 500, second year 1,000, third year 1,500, like that. For next 9 years, he is planned to deposit. For the interest rate of 15 percentage, find the total amount at the end of 10th year of the above series. So what are the given? A1 is given, that is 4,000 every end of the year he has to pay, and additionally after 1 year he has to pay rupees 500 for interest rate. I is equal to 15 percentage, N is equal to 10 percentage. So he has to find the equal amount A and the present worth method, the present worth amount. And this is the corresponding cash flow diagram. Initially, he has to deposit 4,000, and the next year 4,000 plus 500, and third year 4,000 plus 1,000, 500 plus 500, and the fourth year 1,000 additionally 1,500, like that. Up to 10th year he has to deposit. Then you have to put it in the formula, the value, corresponding value. So we can get it 5,691.60 rupees. And this 3.3832 value you can get it from the interest table, or you can use the formula to find the particular value. So this is equivalent to paying an equivalent amount of rupees 5,691 at the end of every year for next 10 years. The future worth sum of this revised series at the end of 10th year is obtained as follows. You already discussed in the present worth method. The same formula we have to use here to find the present worth, right? Or you can get it from the interest rate table also. So the values are rupees 1,15,562.25. So at the end of 10th year, the compound amount of all his payments will be rupees 1,15,562 he will get after his retirement life. So this is the use of to find the value through the uniform gradient serial annual equivalent. So I hope you understand this concept. Thank you.